Hey everyone, and welcome to The Explainer. Today, we're jumping into a framework that is, honestly, a total game changer. It's all about helping your students move beyond just knowing the facts to actually truly understanding the concepts. And we're going to do it by making their thinking visible. So let's start with something every single teacher has experienced, right? You've got that student who aces the multiple choice test, but when you ask them to explain the concept in their own words, they just can't. They know the what, but they can't get to the why. It's such a common and, let's face it, frustrating problem. Well, there's a name for this. It's the gap between knowing and understanding. But here's the good news. We can absolutely build a bridge across that gap. And today, we're going to give you some incredible, research-backed strategies to do just that. The core idea here is all about making student thinking visible. And the absolute key to unlocking that is something called representation. It's literally about getting the thoughts that are swirling around inside a student's head out into the open where everyone, including the student themselves, can really look at them. So what are we even talking about when we say representation? It's just the act of taking an idea and turning it into something you can see or touch. It's a way to organize your thinking so you can explain it. And look, the important thing here isn't making a beautiful final product. Nope, the real learning, the deep stuff, happens in the messy process of just trying to create it. And you need to know, this goes way beyond just drawing a diagram. A representation can be almost anything. It could be a gesture with their hands to show a process. It could be building something with Legos. It could be a really good analogy that connects a new idea to something they already know. The possibilities are huge, and that's what makes this so powerful. It gives every kid a different door into the same complex idea. This quote just nails it. Representations help learners externalize their thinking so it can be examined, questioned, and improved. See, once that thinking is out in the open, it's not some private mystery anymore. It's a real thing that we can talk about, we can poke at, and we can make better together. Okay, so that's the big idea, the why. Now let's get into the how. We're going to walk through 6 practical strategies. Think of it as a toolkit you can start using in your classroom, like tomorrow. First up, we've got a really cool one called representation translation. The idea is simple, but wow, is it powerful. You're basically asking students to explain the exact same idea, but in a totally different format. So here's how it works. You give them a concept, they explain it one way. Maybe they write a paragraph. Then, here's the key, you say, great, now translate that into a drawing or a flowchart. The magic really happens in that final discussion when you ask, so, what did the drawing show us that the paragraph couldn't? That question forces them to think deeper, not just repeat what they already know. All right, strategy number 2 is build to explain. This one is all about getting kids moving, getting their hands dirty, and building models to show what they're thinking. And remember, the goal here is not to build a masterpiece. It's all about how well they can explain their creation. They build something, and then they have to walk you through it, explaining, this part represents this, and I put this here because... A simple gallery walk turns into this amazing learning opportunity where they see how their friends solved the same problem, which sparks new ideas and gets them excited to revise their own work. It's learning in motion. Number 3 is compare and connect. This is where we really start to sharpen those analytical skills by putting different versions of the same idea right next to each other and asking, okay, what's going on here? This strategy builds such a critical skill. So you might show a data table, a written paragraph, and an analogy, all explaining the same concept. Then you just ask, what's the same? What's different? Which one would be best if you wanted to see the final outcome versus the process? You're helping them see that different tools are for different jobs, which is exactly how experts think. Our 4th strategy, student modeling and revision, is all about changing how we see learning. It's not a one-and-done thing. It's a living, breathing process. This is such a huge mindset shift. A student makes a model of what they understand right now. They get some feedback, they learn something new, and then, and this is the most important part, they go back and change their original model. That final question, how did your model change and why, makes their learning journey visible even to themselves. It shows them that it's okay, actually it's great, for their understanding to evolve. Strategy 5 is where we bust down the classroom walls. It's called model-to-world connections, and it's all about linking what we're learning to what's actually happening out there. So with this one, we're basically stress testing our classroom models against the real, messy world. You ask questions like, okay, where does this science model work perfectly? And then, even more importantly, where does it kind of fall apart? That second question is where the real learning kicks in. It pushes kids to make their understanding more nuanced and helps them build that crucial skill of actually using what they've learned. And that brings us to our final strategy, number 6, representation reflection. This is all about building the habit of metacognition, thinking about your own thinking. It's so simple, but it's so powerful. Every so often, have your students just look back at all the drawings, models, and explanations they've created. Then ask them, which one of these really made the idea click for you? Which one is still a little confusing? This helps them see not just what they learned, but how they learned it. It turns them into smarter, more strategic learners. So, that's the whole toolkit. But what does it actually look like when a teacher puts these strategies into practice? Let's take a look at the journey, from just starting out to really innovating with these ideas. On one end, you have a teacher who's just beginning. They might show a model, but the students are pretty passive, maybe just copying a diagram. But on the other end, at the innovating level, the classroom is totally different. The teacher is more like a designer, constantly creating chances for students to build, to connect, and even to critique different models as real tools for thinking. Now, don't worry about reading every single word here. Just look at the big picture, the flow from beginning on the left to innovating on the right. Just take a second and think, where are you and your students on this journey right now? This isn't about judging yourself. It's a map. It's just a way to figure out what your next step might be. And really, it all boils down to this one critical mindset shift. The goal is to get to a place where you can say, I recognize that representations are tools for reasoning, justifying, and proving, not end products. The real value is in the messy process of thinking, not the pretty poster at the end. So, to wrap this all up, I want to leave you with a challenge, a call to action. Think about what you're teaching this week. What is one idea, just one single concept, that you could ask your students to show you in a new way tomorrow? Just asking that one simple question could unlock a whole new level of understanding for them and for you.